Hello everyone, I'm Luisa Palechor and I'm going to present our paper, How are Solidity smart contracts tested in open source projects, an exploratory study. Academic and industrial attention in blockchain technology has exploded in recent years. The reason why is because blockchain enables trust between entities without the involvement of a third party by storing permanent and unalterable blocks that ensure the integrity of the stored data. New data can be stored on the blockchain in several ways, one of them being through the smart contracts. But what are the smart contracts? A smart contract is a self-executing script of which the proper execution is given when predefined conditions are met. This definition of smart contracts was first made by Nick Szabo in 1997. He also compared the smart contract definition with a vending machine because the machine takes in coins and via simple mechanism delivers change and products according to the display price. Anybody with coins can participate in an exchange with the vendor. Nowadays, the smart contract concept is still the same, plus they can run in blockchain networks. Let's check next example to clarify the concept. Imagine Robert wants to transfer the ownership of his house to Mari. First, Robert needs to read over the deed to check that all information is accurate and complete. Second, Robert has to sign the deed in front of a qualified notary public and any other witness required by the law. Finally, to complete the property transfer, Robert has to take the deed to the register office to be filed. At the end of this process, the register office should have Mari's name on file as the new owner. Let's move to the same task, transfer the ownership of Robert's house, but now by using a blockchain-based application and smart contracts. Imagine Mari transfers her payment to buy the house into the account that was agreed. The contract validates the amount transferred, and if it is correct, the contract transfers the ownership of the house to Mari. Otherwise, it will reverse the payment and Robert will remain the house ownership. The benefits of using smart contracts are that they cannot be manipulated and no third parties are needed for interpretation as a lawyer, notary, or public registry. As I mentioned, the smart contracts are added to blockchain networks, and depending on the blockchain they are stored, completing the transaction could take only a few seconds. One of the most popular blockchains to support smart contracts is Ethereum. Ethereum was designed by Vitalik Buterin and it was first released in 2015. Ethereum primary code language is Solidity, and this code language has become the most popular one for defining smart contracts. However, Solidity is an immature language. It changes continuously. This represents a big challenge since once smart contracts are deployed and added to the blockchain that cannot be modified. Solidity current version is 0.8.13, which according to semantic versioning means it's still in initial development and anything may change at any time. Solidity cannot be considered stable. The problem is sometimes Solidity new versions do not always have backward compatibility, which makes hard to ensure the correctness of code, especially for a long-running project. Running attack is the most recent attack in cryptocurrencies, leading to a $625 million loss. Nevertheless, smart contracts have a wider field of application. They can be used in health or educational field. They can even be related to humans' life, and having issues could be catastrophic. Previous studies have proposed solutions to create high-quality smart contracts. Some have introduced new testing tools and others improve existing ones. We checked some of the existing tools for testing Solidity smart contracts. We found different testing tools supporting different languages. For example, Brownie supports Python and Truffle supports JavaScript and Solidity. Another useful testing tools we found are the Testnets, which are sandboxes that emulate the blockchain networks. They are blockchain copies where developers can deploy the smart contracts in a risk-free environment without worrying or breaking the main chain. Here, developers can interact with others by sending and receiving transactions to test functionalities without the need of real coins. We notice that there is an effort to improve smart contract testing, but recent surveys have revealed that open source developers grumble about the lack of support for testing smart contracts compared to that for testing traditional applications. We found there is a gap between what is required by developers and what has been offered so far. That is the reason why we perform an exploratory study on how Solidity smart contracts are tested in open source projects, asking next research questions. In the first research question, we study which developers are involved in smart contract testing to get a better idea of how this task is approached in open source projects. We believe testing Solidity smart contracts is not a popular contribution to make for open source contributors. Second, we investigate which tools and testnets developers use to test smart contracts to reveal which testing approaches developers take in practice. Finally, in the third research question, we investigate which tests developers conduct on smart contracts to overcome these challenges. First, we started collecting data from Solidity projects located in GitHub. We created a custom query in August 2021 to obtain active Solidity projects. We limit our research to Solidity projects with at least 10 stars and 100 commits. Likewise, we only consider non-archived projects. This with the aim of obtaining mature projects. We excluded tutorials, repositories with no descriptions, and testing frameworks, libraries, and tools. Then we check the project's files to identify test files and configuration files. To solve our first research question, we determined the core team of the project. Following the approach in our previous work, we identified the top N developers working on the project, where N was the total number of developers coding test files. We identified these N developers as the core developers of the project. Next, we manually deduplicate developers' names. For example, in the project we merged the records for Fernando Martinelli with and without a space, as they were clearly pointing to the same person. We found a median of 80% of the test developers was also part of the core team. The figure shows a violin plot with the ratio of developers in the x-axis and core test developers in y-axis. This result suggests that testing smart contracts is a responsibility of core developers, and having contributions from external developers is unlikely. For our second research question, we manually checked the configuration files, makefiles, YAML files, and testing files, and extract testing tooling data. We observed that the most used testing framework is Truffle, followed by Hardhat and GitHub tools. These three tools are mainly used for unit testing. Moreover, we found that 34.5% of the projects don't provide information about using testnets as part of their testing process. These results suggest that these projects may test the smart contracts in a private blockchain without interaction of existing smart contracts. For example, a private blockchain offered by Truffle, Hardhat, or the app's tools. Another explanation is that testnets are used but configured locally, for example, within an integrated development environment. Such configuration would imply that the tests are not intended for automated execution, for example, within a continuous integration pipeline. We also found that Kovan, Ringby, and Robston testnets are the most popular. This is not surprising since these testnets are meant to test smart contracts in Ethereum, which was the first blockchain to support the smart contracts. We also observed that while the median number of used testnets is 1, several projects tested smart contracts on more than one testnet. Depicts the distribution of the number of testnets per project. The outliers are from projects that support smart contracts in multiple blockchains, such as Polygon, Ethereum, and Binance. Moving forward, in the third research question, we reviewed the obtained files and kept the files that provided data about the unit and integration testing, performance test cases, and used testing tools. After reviewing the test files, we found that 6.5% of the projects don't provide details about how they test their smart contracts. After inspecting each of these projects, we didn't find test-related code. We highlight, however, that 3 of the review projects may include test files privately. For example, the Bunny project contains audit reports files which specify the code coverage index for 4 smart contracts, the test report of 95 scenarios, and 1 vulnerability analysis report. Furthermore, in one smart contract project, the ignore file defines tests within the list of its untracked files. We also observed that 93% of the projects in our data included functional testing as part of their testing strategies. 58% of the projects included testing in the continuous integration pipeline. We noticed that the tools used were Actions, Travis CI, and Circle CI, similar to traditional open source projects. We also found that less than 10% of the projects conduct security tests. We observed that fast testing and audit reports are used to test the security of smart contracts. For example, through fast testing by feeding the code with random and erroneous data. And finally, 24.5% of the study projects included audit reports performed by third parties. The audit reports have different formats across projects, but overall, they show the smart contract's potential vulnerabilities and provide recommendations for improvements. Here I conclude my talk. I explained the concept and the importance of the smart contracts and presented an example of a smart contract-based application. I explained the current problem and the motivation for our exploratory study by showing that even there exists testing tools for open source projects, developers complain about the lack of support. And finally, I presented the results of our exploratory study. My name is Luisa. Here is my email address. Feel free to contact me if any additional questions. Thanks for watching.